Okay, saya dah start record untuk kelas ni. Okay, I already recorded this class. I will speak to you in English because I will upload in YouTube for you all and all international student in the future for them to hear this lecture so that everyone can get benefit from this lecture. Okay, this is continuation from the last week's topic is on the flat and round bed drive. Okay, so the challenge in this subtopic is the calculation. Okay, how to make the calculation on the flat bed drive. Okay, modern flat bed drive consists of the strong elastic core supported by elastomer. Okay, it meaning that from the material side, the belting is made on elastomer. Okay, uh, this drive has distinct advantages over gear drive or V-belt drive. Okay, a flat belt drive has efficiency about 98%, which is about the same for a gear drive. On the other hand, efficiency V-belt drive is about 70 to 66%. Okay, a belt drive produce very little and absorb more torsional vibration for the system than either V-belt or gear drive. Okay, you see because flat belt is flat. Okay, the nature of the flat structure, uh, it has, it can absorb more torsion vibration, meaning that vibration from the torsion effect lah. From if you do the torsion effect, it can effect. Okay, it can absorb the torsion. Okay, so now we see about the calculation, how to make the calculation derivation on the subject. When open bed drive, figure 171A. Okay, 171A. 171. Okay, 171A is here. 171A is here. Okay, when you study this topic, you can refer to this diagram. Okay, this is the 171A picture. Okay, okay, the contact angles found to be theta d equals to pi minus 2 sin negative 1 d minus d over 2c. You see here, d theta refer to angle of contact, d refer to the small gear, d capital D refer to the big gear, large pulley or small pulley, or okay, the same principle lah, large gear, small gear or pulley or everything. Then pi minus 2d 2 sin. Okay, 2 arc sin. Okay, so and the difference is d plus. Okay, because you can see here in 17.1a. Okay, 17.1a, you can see this is the upper one, this is the lower one. Okay, this is the upper belt, upper portion, this is the lower portion. One of them will become minus and one of them will become positive. Okay, the difference is the minus and the here this is the plus. Okay, because one will become tension and one will become tension opposite, tension and compression, tension versus compression, but in this case it will become slightly deep. Dia kendur lah, dia kendur dalam in Malay we call kendur lah, kan? Okay, okay, okay. So we want to find the length of belt. Okay, length of belt is found by summing the two arc length with twice the distance beginning the end of contact. The result is L equals to 4C. For C is referred to the center distance minus D over D equals to 2 punca plus 1/2 D theta D. Okay, this is equation 17.2. Similar set of equation can be derived from the cross belt. For this belt, arrive of angle the same of both pulley is theta equals to this. Okay, talking about angle of contact, what is the really meaning of the angle of contact, you know. Okay, what is really the meaning of angle of contact? You see here in this picture, this is the angle of contact. Okay, uh, this is the angle of contact. You see here the you can imagine belting the belting in contact with the pulley. You have it will contact if in such an angle. Imagine this is a bigger pulley or smaller pulley. The angle of contact will be different. Okay, you can see in bicycle, for those who like to bicycle, you have to cycle, you have a different gear, and gear and large gear, gear number 1, gear number 2, and gear number 10 until gear number 10. The difference is the you see the gear in the bicycle is they have big until small gear. Okay, all of them has angle of contact, you know. All of them has angle of contact. Okay, we for those who like to bicycle, who like to cycling, they know better lah, kan. Okay, all of them has angle of contact to each other. This is the difference of angle of contact. Okay, the question is, what is the belting that is suitable, the length of belt that is suitable for that bicycle. Okay, Fairbank explained flat belt drive theory in the following way: a change in belt tension due to friction or force between belt and pulley will cause the belt to elongate or contract, okay, and move relative to the surface of the pulley. Okay, meaning that a change of belt tension due to friction force, okay, because the belt is connected to the pulley, so one of them will contract and one of them will become tension. Okay, will become elongate. Okay, will become elongate or contract, meaning that it become tension, or opposite tension is compression. But in this case, we don't call it compression, we call it as contraction and elongation. Okay, and move relative to the surface. The motion is caused by elastic creep. Okay, the word creep here, and it's associated with sliding friction as opposed to static friction. Okay, okay, because sliding, the pulley, okay, the pulley, when contact with the flat drive, it become sliding. Okay, the action of driving pulley that through that portion of angle contact that is actually transmitting power is such that the belt move more slowly than the surface speed of the pulley because of elastic creep. Okay, that belting is in contact with the pulley. Okay, of course, when you learn, if you can remember the uh, the topic in journal bearing, last topic I taught you about the journal bearing. Okay, the motor has some speed, has a speed, but in that journal bearing, okay, in sliding, in that journal bearing mechanism, the speed inside the journal bearing is different. It's slightly slower than the speed of the motor. Okay, the same principle here. Okay, because it is in contact with the surface, okay, with the pulley, so that it basically is moving quite slow, but not that critical slow that you cannot you may not notice, but it's in theoretically it is quite slow, relatively slower a bit than the actual speed of this motor. Okay, the angle of contact is made out of the elastic effective arc, through which power is transmitted, and the idle arc. Okay, for the driving pulley, the belt first contact with the pulley with tight right tension F1 and velocity V1. Okay, the term used here as F1 now. Okay, you will see the word F1 in many times in the equation. Just remember, F1 refer to tight right tension. Okay, tight side tension. Okay, tight side tension. Okay, and velocity V1, which is the same as the surface velocity of the pulley. Okay, the belt then pass through an idle arc with no change in F1 or V1. Okay, what is an idle? If you remember the topic gear, there is a idle gear. It's only to transmit the power, to transmit the because they have the opposite direction of the gear. Okay, it must be connected to an idler. The same principle here. Okay, it will give no change in force. Okay, no change in tension and no change in velocity. It only change the direction. Okay, and the creep and sliding contact begin, and the bolt tension changes in accordance with friction forces. At the end of active arc, the belt leave the pulley with loose side tension F2 and reduce speed V2. Okay, remember the word F1 and the word F2. Okay, you will meet again and again in all this equation. Just remember F1 is tight, F2 is loose side, and velocity is the velocity given by the motor, and after V2 velocity after the reduction. Okay, if I say motor, it may be not correct. If you are imagine you are in a bicycle, you are riding in the bicycle, the force, the velocity is given by your leg. Okay, the velocity is given by your leg. This is V1. Okay, and then after you riding, you feel you will feel reduction of speed. That is a V2. Okay, Fairbank has used this theory to express mechanics of flat drive in mathematical form and have verified the result by experiment. Okay, his observation include the finding that substantially more power is transmitted by static friction than sliding friction. Okay, more power is transmitted by static friction than sliding friction. Also found that if coefficient of friction of a belt having a nylon core, a ladder was typically 0.7, but it could be raised to 0.9 by employing special surface finish. Okay, this you know about the friction lah. Okay, typically 0.7 because reduction of course all the surfaces have friction, but if the friction is given by special surface coating, the friction will become 0.9, meaning the ideal one is 1.0 lah. 1.0 but of course nothing in this universe can reach 1.0 efficiency lah, kan? Okay, we can only reach 0.9999, cannot reach 1.0. Okay, meaning if friction is 1.0, there is no friction. Nothing in this world have no friction. Okay, but if you go to outer space, maybe have zero friction lah, kan? Our model, we assume that friction force on the belt is proportional to the normal pressure along the act of contact. We seek first a relationship between tight side tension and slack side tension, similar to that band brake, but incorporating the consequence of movement and that is centrifugal tension in the belt. Okay, remember tight side tension is F1, slack side tension is F2. Okay, this F1 and F2. Okay, similar in figure 17.6 here, this figure, we see a free body of a small segment of the belt. Okay, small segment of this is a free body diagram of the belt. Okay, differential force ds is due to centrifugal force, dn is normal force between the belt and pulley, f friction, dn is the shearing friction due to the point of slip. The belt width is b and the thickness is t. Okay, the belt per mass unit length is m. Centrifugal force ds can be expressed as this equation. Okay, so regarding about free body diagram, okay, this is what you have learned in year 1 before. Okay, how to make a free body diagram, how to explain this free body diagram. It is one only, you take imaginary portion, you take this one portion, and when you take this one portion, they have this portion, ds you know from the mathematics. When you learn mathematics before, the Malay word is sesaran. Okay, the Malay word lah, kan? This is the radius. This is the length of the the length lah, the length of the curve, the length of the curve. Okay, if that curve is taken as a straight line, this is the S lah. Okay, and then they have the normal force, and of course with friction you must add the friction with it, so friction dn. Okay, this is the velocity and this is the force. Okay, so force plus difference of velocity, this is the radius and theta and everything. Okay, um, the belt width is B and the thickness is T. The belt mass per unit length is M. Centrifugal force ds can be expressed as ds equals to m r d theta rw power of 2 equals to mr. This is I'm sure you are familiar. This is the equation for radial velocity, the angular centrifugal force velocity. Okay, and this is mv equals to 2 d theta fc. C equals to c fc d theta. What is fc? Fc. And b is the belt speed, and summing force radially given by force radial, okay, equals to negative f d theta and everything. ds equals to 0. Ignoring the higher order form, we have dn equals to f d theta minus ds. Okay, summing forces tangentially equals to this is equation, from which incorporating equation a and b we obtain df equals to friction dn equals to friction d theta minus friction ds. Okay, equals to this equation. So you have df over d theta minus df f equal to minus f mr cos 2 omega cos 2. Okay, power of 2. So the solution is non-homogeneous first order linear differential equation. So you have the fa a expression f theta where a is arbitrary constant. Okay, assuming theta start at loose side, the boundary condition f at theta equals to 0 equals to f2. You remember, f2 is the loose side. Okay, loose side given a equals to f2 equals to loose side minus f mr cos 2. Solution if f equals to f2 minus mr cos 2. Okay, at the end of the wrap, theta, the right side, equal to this equation. Now we can write f1 over minus, you can get this equation. So written by as f1 minus f2 equation, this equation. So fc is found as follow, with n with rotational speed, and belt speed is v equals to theta dn per 12 in feet per minute. Okay, in feet per minute, this is the unit in feet per minute. Okay, and weight w of a foot of a belt given in term of the weight density gamma in pound per inch equals to w equal to 12 weight density bt pound per feet, where b and t are inches. Okay, fc is written by this equation. Okay, this equation, w per 32.17, v per 60 kuasa 2. Okay, so figure 17.7 shows a free body diagram of pulley. Tight side of tension, the loose side tension F2 have the following additive component. Okay, this is the following additive component. We have F1 is the initial tension, Fc is the hook tension, do centrifugal force. Okay, Fc is the hook tension. Okay, different F over 2 is tension due to transmitted torque. Okay, D is the diameter of the pulley. Okay, difference between F1 and F2 is related to torque pulley. Pulley torque, subtracting the equation F, it gives F1 minus F2 to T over D. Adding equation F and G give this equation. So okay, and from which initial tension equals to F1 plus F2 minus over 2 minus hook hook force. Okay, hook force, hook tension. FC equal to hook tension. So manipulating equation using equation 77, give this equation. So from which initial tension equal to this equation. Okay. Uh, Thus gives a fundamental insight into flat belting. If F1 equal to 0, then T equal to 0 with no initial tension or no torque transmitted. Exactly what is initial tension F1 ni? What is the scenario of equal tension? Okay, imagine when you are riding a bicycle. Okay, when you are riding bicycle, the belting is on the pulley itself. Okay, you see the belting in your bicycle. Okay, when you inserted the belt into the belting, it already have the initial tension, kan? Meaning that one, you can see by your eye, you can see using your eye, physically, one is contraction and one is elongate, one is contract, meaning that one upper side is tension, lower side, no, below side is tension, upper side will become slightly deep. Okay, kendor lah, kan? And that F1 is the initial tension lah. That one F1 is initial tension. Okay, if F1 equal to 0, meaning no belting, there is no belt. Okay, no initial tension, no torque transmitted. Okay, the torque is in proportion to the initial tension, meaning that if there is to be necessary belt drive, the initial tension must be provided, sustained in a proper amount and maintained by routine inspection. Okay, meaning that when the belting, the mechanism is off. Okay, the mechanism is off, the machine is off, the machine is offline, your bicycle not moving. Okay, initial tension, you must be sustained. Okay, proper amount and maintained by routine inspection. Okay, that is what the meaning by this lah. Okay, incorporating figure 79 give F1 F1 is tight side tension equal to initial tension plus tension of the hook. Okay, T over D, okay, equals to this equation. Okay, equal to this equation, and you get this equation. Okay, and then from equation G, okay, incorporating equation 79 to 1710 ni, you get this F2 is the loose side tension, okay, equals to initial tension plus FC hook stress minus F T over D. Okay, and then you get this. Ada soalan? Have a question? Okay, and then you get this lah. That is why when you see all this kind of equation, all this kind of equation, you have exponential, you have arc, sin and everything. That is why the reason I advise you to learn using MathWay and also Wolfram Alpha, because it is easier for you to write the equation in MathWay and Wolfram Alpha, comparing to your scientific calculator. Okay, compared to scientific calculator is much more difficult. Okay, I advise you to learn using MathWay and Wolfram Alpha, because you can insert this equation easily. Okay, and then you can get the answers straight away. Okay, equation 77 is called belting equation, but equation 79, 10, 11 reveal how belting work. With 77, what is 77? We see again, this 1710, 79, 17. This is the 77. This is the belting equation. This is the belting equation. Okay. And then initial tension need to be sufficient that the difference between F1 and F2 curve is 2T over D. That is when no torque is transmitted. The least possible back tension is F1 equals to F2 equals to FC. no torque transmitted. What is mean by no torque transmitted? Meaning that machine is off lah. Machine is off. Your bicycle is not moving. Okay, meaning that no torque given to the belting lah, kan? So the transmitted horsepower is given by H. H is for horsepower. So H equal to F1 minus F2 V with the velocity over the 33,000. Okay, where the forces are in pound and V is in foot per minute. Manufacturers provide specification for their belt that include allowable tension FA, okay, or stress at all the tension being expressed as unit for force per unit weight. Belt life is usually several years. The stability of flexing of the pulley and its span life is reflected in a pulley correction factor CP. Speed in excess of 600 feet per minute is effect on life reflected on velocity correction factor. Okay, for polymer routine belt, use CV equals to 1. For leather belt, A service factor used for equation of load for nominal. Okay, what is the meaning of these sentences? Okay, I like you to imagine the bicycle you use at your house. The bicycle, if your mother or your grandfather have a bicycle used to cycle to the mosque, used to cycle to the mosque or cycle to the market. That kind of bicycle is not for racing. That kind of bicycle is not for racing. Okay, if you do that bicycle for racing, God forbid that the belting may break away, kan? Because it cannot sustain the speed, the higher speed. Okay, but the bicycle used by our cyclists like Azizul Hasni, our cyclists lah, like Azizul Hasni Awang, he has that kind of bicycle, has the speed, can sustain more speed lah, kan? Sustain more speed. He use the better material, use the better speed and mathematics with, okay, and then it can go for higher speed lah, kan? Okay, so this is a figure 78. 78. This is figure 79, the velocity correction factor and everything. Okay, applied to nominal power, HD nominal power HD equals to H nominal K S and D, where ND is a design factor for exigencies. Okay, this effect are incorporated as follow. F1A equals to BFA CP CV. Okay, what is F1A? Is the allowable largest tension. Allowable largest tension in pound. The maximum the tension it can be. This is the F1A lah, kan? Okay, this is the meaning that over this limit, the belting will break away, rupture and everything. We don't want that to happen lah. This is the allowable belt tension. This is the belt width inchi. This is the FA, manufacturer's allowed tension. CP, the pulley correction factor. From table you have to see the table. CB is the velocity correction factor. Okay, this is the step to analyze effect by drive. Okay, find exponent F theta from back drive geometry and friction. From back drive geometry and speed, find FC. Okay, hook tension. From T equals to this equals to 63,000 H nominal KN. Find necessary torque. From the find the torque necessary for largest allowable tension minus loose tight loose tight side of the tension F2 equals to 2 T over D. Tables 17.2 and 17.4 equation determine the largest over tension. Find F2 equals to F1. Find equation, find necessary equation initial tension. Check the friction development. Okay, friction development. F prime must be lower than F. Okay, and then F prime equals to 1 over theta ln F1. Find the factor of safety. Okay, this is the step. This is the step. if you see the problem in the if you see the problem and solution in the solution manual, you can find one of the problem talk about this step. Okay, you can find one of the problems in the question, find talk about this step lah. You should follow the step. Imagine when you have to design a machine. Okay, when you have to design a machine, the machine require a belting. This is the step for the belting. Okay. Okay. Don't worry, the it is in the solution manual lah. It is unfortunate that many of the available data of belting are from sources in where they are presented in very simplistic manner. Resources use a variety of charts, monograph and table to enable someone who knows nothing about belting to apply them. Okay, little if any computation is needed for such a person to obtain valid result. Since a basic understanding of the process in many cases is lacking, there is no way this person can vary the step the process can vary the step in the process to obtain a better design. What does it mean? Okay, it means that for the layman person, the person who have no knowledge on bicycle on calculation of belting and something, they only rely on the spec of the machine and everything. They just choose all over the shelf. Okay, they go to the shop, they choose, they ask the shop what is the better belting for them, and the shop we suggest this kind of belt. Okay, if you have the knowledge on the calculation and everything, you can design a better belt. Okay, meaning that maybe you have you can only have to buy cheaper belt, but it can function for the better one, the better function. Okay, this is what is meaning by this lah. Okay, this is the process you have to face step 1 until step 9 to find the necessary belting. Okay, incorporating this the available belt drive data into a form that provide a good understanding of belt mechanics involves certain adjustment in the data. Because of this, the result from the analysis presented here will not correspond exactly to with those of the sources from which they are obtained. Okay, a moderate variety of belt material with some of the properties are listed in table 17.2. They are sufficient. These are sufficient for solving a large variety of design analysis problem. Okay, so you can see table 17.2 here. These are some guideline. If you want, you choose the material for leather. This is 1 ply. This is 2 ply. For polyamide, for or also for urethane, meaning that this is the common type of material for a flat belt. Okay, common type of material for flat belt. Okay, you see the size, you see the minimum pulley diameter, allowable tension, specific weight, and coefficient of friction. Generally like this lah, kan? Okay. Of course, if you are dealing for some specific material, the company, the shop will also provide some similar table like this. Okay, so that you can buy, you can choose. This is the textbook. This textbook is taken from most common example, of course. But when you are in industry, you may encounter many kind of material, many kind of belting. The thing is, the idea is you know how to read it. You know how to read and you know how to choose. Okay, you know how to read and you know how to choose the material. First of all, you know what is the material for that belting that you want, and then you find the specification, and then you adjust your drawing, your design of the machine according to the material of the belting and everything lah. Okay, flat belt pulley should be crowned to keep belts from running off fully. If only one pulley is crowned, it should be larger one. Both pulley must be crowned whenever the pulley is not in horizontal position, meaning that if uh, you must have uh, you must have uh, the edge of it, if not the pulley will fly away, the belting will fly away. Okay. They are, if imagine you have the thread, benang or tali rafia and everything, you can see the diameter is small now. Okay, when the diameter is small, when you when you tarik, when you pull it, it will it will fly away now, kan? It will fly away from the pulley, kan? But if you have the flat belt is large, the diameter is large, and not the diameter, the width is large, it will not easily fly away, kan? Okay, it's not easy. This is what meaning by crown lah, kan? Okay, this is the pulley size, table 17.3, table 17.4, and table 17.5 and everything. I have go to with some solution for this example, for this belting and everything. There are a lot of tables you have to refer. You have to refer a lot of table. That is why uh, for the testing, for the test, for the quiz and everything, it is must be open book, because you have to rely on the table. If examination like past year examination, everything, a lot of table we have to give to the in the examination. Okay. Okay, this is the among the question. Example 17.1 is an example. Okay. Okay, take 5. Okay, take 5. Baik. Baik, okey. Uh, okay, this is example 17.1. Polyamide A3 fat belt 6 inch wide is used to transmit 15 horsepower. The light short condition where KS equal to 1.25 and factor of safety equal to or greater than 1.1 is appropriate. Okay. Use the pulley rotational axis are parallel to the horizontal plane. The shaft are 8 feet apart. The 6 in driving pulley rotates at 1750 revolution per minute in such a way that the loose side is on top. The ribbon pulley is 18 inch in diameter. See figure 1710. The factor of safety is for unquantifiable exigencies. You can Google exigencies. What is the mean? What is meaning by exigencies? I just Google exigencies. What is the meaning? Okay, we just this English word is so difficult. Exigency meaning that an urgent need or demand. Urgent need or demand. This is what the meaning by exigency. sometimes the question use bombastic word to make people confused and everything. But now it's modern time. Just Google it and you can find the answer straight away. Okay. Ini that the factor of safety is an important. Is important lah. What the meaning of the sentence is? The factor of safety is important. Okay. The first question is estimate the centrifugal tension Fc and the torque T. B is the estimate the allowable F1, F2, Fi and allowable power HA. Okay. And estimate the factor of safety. Is it satisfactory? Okay. This is the question. How to solve this question? Okay. From equation 7.1, theta is equal to theta d equals to minus d. You can put this. You can get straight away. This is why I want you to learn about using MathWay. MathWay. Okay. I have to show you how to use MathWay. Okay. 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 This is mathway.com. The website that I advise you to learn using this website. Okay. The solution is pi minus 2 sin 1 kan. So pi, what is the symbol for pi? Pi, if you cannot find the symbol is here. The symbol is here. Basic math or basic algebra and everything, you can see algebra. No. Trigonometry. What is the trigonometry? Okay. Okay. You put the symbol pi here. Okay. Pi minus 2. Okay. Sin. Okay. Okay. And then you put the bracket. You put, where is the bracket? Okay. Bracket here. Bracket and this symbol. Okay. This bracket 18 minus 6. Okay. And then you put excuse me, to 8 and then 12 and then close the bracket and then you find the answer straight away. Tekan evaluate. Okay. And then you find the answer straight away in decimal form 3.10165. This is how you learn MathWay. I really advise you to learn by your own using MathWay. Okay. If you want to use Wolfram Alpha, also can, but Wolfram Alpha, it is better for you to write in mathway.com. To write in mathway.com first and then copy paste into Wolfram Alpha. I repeat, write in mathway.com first and copy paste into Wolfram Alpha. It is better like that. It is better like that. Okay. And then you get this form lah. Kan? If you Wolfram Alpha, the advantages is you can see the graph and everything. It will show you how the graph. It will also have the graph, also have the how solution. If dalam kerja lah, it will show the dalam kerja and everything. Okay, both have advantages, both have disadvantages. If you want to use it, better you learn mathway.com first, and then you copy paste inside the Wolfram Alpha. Okay. Learn by yourself, huh? Okay. So have to refer for the table 17.2. You have to find the gamma, the specific weight, the friction, and the allowable. Okay, and then you put in the equation, you get the radial angular velocity like this. Okay, like this. Okay, and then answer for FC, hoof tension equal to like this. Okay, T equals to 7.8. You can have the stress, have the torque, pounds per inch. Necessary allowable stress equal to transmit the power T. You have the 247.6. Okay, necessary allowable tension. For polymer belt, CV equals to 1, table 17.4, CP equals to 0.0. The largest allowable tension, F1A, equals to this 420 pound. Okay, and then for the slack set, the loose side tension, okay, equals to this equation, 172.4. For the F1 equals to initial stress, initial tension equals to 270.6. Okay, combination F1 A, F2 and F1 will transmit the design power HA equals to H nominal KSDN. So you get 20.6 horsepower and protect the belt. Okay, we check the friction development by solving the equation for this friction development. You can see here is 0.328. Okay, the friction here 0.8 is taken from the table lah, table 17.2. You get the friction, allowable friction 0.8. Since you get 0.328, is under the blurb, so no danger of slipping. Okay, if the friction is over it, meaning that it will be slip. Okay, your belting will fly away. Okay, so for the step 9, KP equals to 0. So you get 1.1 as expected. The belt is satisfactory and allow maximum allowable belt tension exists. In initial tension is maintained. The capacity of design power is 20.6 horsepower. Okay, what if you get F1? Okay, the allowable tension is 0.8 now. Okay, what if you get 0.79? What if you get 0.79? Okay, is it in danger of slipping? No, because it is not over. It is not over. Okay, but you should design. You should reduce the diameter or reduce the belting and everything. You make it lower, slightly lower than the allowable friction. I repeat, if you get the answer like this, the allowable tension is 0.8, but you get your answer is 0.79, 0.01 difference between 0.08. There is no danger of slipping, but it is advisable for you to reduce the design so that maybe you have to increase the factor of safety and everything lah. Okay, okay, so make it no danger of slipping lah. Okay, so the capacity of design power is 20.6 horsepower, meaning that this is the motor. You have to the amount of electric power, the amount of oil, the amount of electric bill that you have to pay is 20.6 equivalent to the horsepower lah. You can check with the TMB what is the rate for electric, kan? This is how you count for the electric lah. Okay, so the initial tension is the key to functioning as intended. There are ways of controlling initial tension. One way is to place the motor and drive pulley on a pivoted mounting plate so that the weight of the motor pulley and mounting plate share and a share of weight induces the correct initial tension and maintains it. Okay, meaning that put everything, you put the motor, drive, everything, put in the same place, the same center, so that the weight can be distributed evenly. Okay. A second way is use the spring-loaded idler pulley adjusted to the same task. Okay, both of these methods accommodate to temporary or permanent belt stretch. Okay, see figure 17.1. This is the belt tensioning scheme. Number A is weighted idler pulley. Okay, number 2 is fibered motor mount. Okay, number 3 is centenary induced tension. Okay, this is how you make it the belt test tension lah. Okay, because flat belt were used for long center to center distance, the weight of the belt itself can provide initial tension. Okay, the static belt deflect to an approximate centenary curve, and the dip from the straight belt can be measured against a stretched music wire. Okay, this is called the music wire lah. This provide a way of measuring adjusting the dip. For centenary theory, the dip is rated to initial tension by this. Okay, what is a dip? What is a dip? Okay, I found I try to find a better picture for weight belt. I cannot find a good picture to explain deep. Okay, but in Malay it's called kendor lah, kan. Okay, is Malay word is called kendor kan, the deep. Okay, okay, the C is center to distance, W is the weight per foot, F1 is inertial tension. So deep is the deep corresponding to this tension is this equation. So you have 0.14 inch deep. Dia punya kendor tu, range of the kendor tu, deep is 0.14 inch kan. Okay, the decision for set for flat belt can be function, speed, power derivative of reaction of service factor C, design factor, and D, initial tension maintenance, belt material, drive geometry, belt thickness, and belt width. Okay, depending on the problem, some or the last four could be design variable. The belt cross section area is really the design decision, but available belt thickness and width are discrete choice. Available dimension are found from the supplies catalog. Okay, so this is when you want to design a flat belting. This is all the things that you have to consider, which is the function, the design factor, initial tension maintenance, belt material, draft geometry, belt thickness, and belt width. Okay, so this is another example 17.2. Design a flat belt to connect a horizontal shaft to on 16-foot center. Velocity ratio to be 2 to 2.25, 1/1. Angular speed of driving pulley is 60 revolution per minute, and the nominal power transmission is to be 60 horsepower under very light shock. Okay, so the solution here, if you see this solution here, is like the same as the decision flat belt. Okay, so is given, this is the given one, this is the design factor and everything. So the last four could be design variable. So let's make a few more periodization. Okay, so if you decide D equals to 60 inch, diameter equals to 2.25 D, you get 36 inch. So use polyamide A3 belt. Okay, if you the solution is in table 17.2 now. Okay, if you use a polymer A3 belt, okay, polymer A3 belt, the specification of from for polymer A3 belt is this specification taken from 17.2. If you decide to use F1 belt, or urethane belt, everything, all this, the factors, all this, you can be taken from the table 17.2. Or in industry, uh, the manufacturer also have the catalog. You see the specific weight and everything lah. Okay, for the table 17.4, CP equals to 0.94. Okay, for the equation 17.12, you can get the allowable tension. Okay, largest allowable tension is like from this equation, meaning that if the tension is over this, the belting will slip away, or the belting may be rupture. Okay, okay, so this is the power, 70.2 horsepower. So torque is given as 5,310 torque. Estimate the full friction development. The purpose to find the friction development is that you want to find whether the belting is slip or not, maybe slipping or not. Okay, estimate centrifugal tension, FC equals to, in term of belt width B, FC like this equation. So you find from this equation, F1, initial tension of the belt is like this. Okay, 18.67 B equals minus 32 pound. First fraction development is highest level, so you get this equation. So B equals to 8.4 inch. The belt width that greater than 8.4, develop friction less than, okay, then F equals to 0.8. So decision, then you get the the answer, and you get the answer, and then you decide whether the belting is suitable or not. Okay, okay, and then you increase the belting. Okay, and then you get the belt, which is friction development is 0.849, which is less than 0 point. Thus it is satisfactory. Okay, and friction equal to 0.83. Figure of merit available of repeating cost, and then you get the deep 0.470 inch. Okay, that is how you calculate it lah. Is the conclusion is we take some time, but again, you use MathWay and also Wolfram Alpha to help you lah. Okay, you should use MathWay and Wolfram Alpha to help you. Okay, and then you get this diagram. Figure 17 to illustrate the variation of flexible belt tension with some cardinal point during the belt pass. Okay, this is the belt tension lah, kan? Okay. Okay, take 5 minute break. Okay, after this we go for flat metal belts. Okay.
tadi atas tapi ni tadi.
Okay, so now we go to the new topic called the flat metal belts. Okay, flat metal belts. Okay. All right. This is flat metal belt. This is the features for flat metal belts. Okay. You can see throughout the ages before laser is fabricated. Okay, it is in this statement here. In this statement here, the thin flat metal belt with their attendant strength and geometric stability could not be fabricated until laser welding and thin rolling technology made possible belt as thin as 0.002 inch and as narrow as 0.02 inch. Okay, the indication of perforation allows no split application. Okay, now throughout the ages, before laser is invented, there are no such thing as flat metal belts. Okay, no such thing as flat metal belt before laser. Now you learn about laser. Laser is an advanced technology. Okay, uh, okay. When people invented laser, okay, the application of laser is so advanced now. Okay, so it can be laser welding. So because um, people can welding thin thin structure lah, because you know about welding, you learn about welding before. Welding involve high temperature, meaning that thin structure will become cair lah, lebur lah, kan? Okay, we become lebur lah. Okay, because of the high temperature. But because of welding focus the temperature in very small space. So laser welding can make flat belt possible. Okay, okay. So the flat belt exhibit high strength to weight ratio. Okay, dimensional stability, accurate timing, useful for temperature up to 700 Fahrenheit, good for electrical and thermal conduction properties. This is the advantages of metal lah. Kan, of course lah, metal is better than elastomer lah, kan? Okay. In addition, the stainless steel always offer inert, non-example belt suitable for hostile or corrosive environment, can be made for sterile or food or pharmaceutical application. That is why for food industry, they have food grade. For materials for food grade, you cannot take any kind of material, but you have to take the food grade material lah, for your industry lah. Okay. This is the requirement for Malaysia. Also for throughout all over the world, requirement for food industry. Okay. Okay. Feature 17.3. Okay. Feature 17.13 shows a thin flat belt with tight tension F1 and slight side tension F2. Reveal relationship between F1 F2 and driving torque. T is the same as equation H. Equation 17, 9, 10, 11 also apply with the hook tension due to centrifugal force typically neglected for very thin metal belt. For largest allowable tension, okay, 17.2 is posed in terms of stress in metal belt. Bending stress is created by making the belt conform to the pulley and its tensile magnitude. Okay, it's given by, okay, stress for the belt equals to ET. E is young modulus of the material of the metal, 1 minus V, power of 2 D over T. So E is the Young modulus, T is the belt thickness, V is the Poisson ratio, D is the pulley diameter. Okay. Uh, just to remind what is the Poisson ratio, I am sure this you have learned before in material subject. Okay, material subject. Just to remind. This is the Poisson ratio, lateral strain over longitudinal strain. Okay, lateral strain over longitudinal strain. What does it mean? Imagine when you crush an aluminium tin. You drink aluminium tin, Milo, Coca-Cola, everything. Aluminium tin kan. When you crush, you step on it, you crush it. Okay, the width become the height become slow, become thin, the width become more fatter. Again, okay. So this is the longitudinal strain lah, called the Poisson ratio. Okay, the Poisson ratio represented by the word symbol V lah. Okay. So the tensile stress is supposed by back tension F1, F2. Remember, F1 is the tight side. Okay, the F2 is the loose side. Okay. So tensile stress equal to F1 over Vt, and tensile stress 2 equal to F2 over Vt. This is one represented the tight side. F2 represented the loose side. Okay. Remember, all the betting have tight side and also have loose side. Okay. Although the belts are simple geometry, the method of marine is not. Yeah, ada soalan? The method of marine is not used because the condition of bar wetment to form the loop is not accurately known. Okay. The method of marine, I go through the text. Is not mentioned anywhere in this chapter belting. In my opinion, maybe the author maybe misplaced the method of marine. Maybe in other subject lah, other subtopic and everything lah. Okay, because it only mentioned the method of fur bank before, does not mention the method of marine in this subtopic of belting. Okay, you can check the method of marine. Okay, in previous chapter. Okay. Okay, the method of marine is not used because the condition of bar wetment to form the loop is not accurately known, and the testing of wet coupon is difficult. Okay, the belts are run to failure on two oversized equal size pulleys. Information concerning fatigue life issued in 17.6 is obtained. 17.17 is give additional information. Okay, what is the meaning of this? Okay, what is the meaning of this? Okay, because this is flat belt. It made from metal. It's made from metal. Previously we talking about elastomer. Elastomer is made from elastomer lah, kan? Urethane, polyamide and everything. This is a different kind of material. But okay, so that is why they have the can be elongate, it can be contraction. Okay, but when you dealing with metal, okay, the only economical way to test it elongation is to test it until it fail. Okay, you have two equal size pulley, the same size pulley, and you run it at high speed. Okay, and when it run at high speed, of course it will fail because of the slippage. Okay, the metal bag will become fly away. The metal bag will become rupture, everything, meaning that it will become failure lah. And when failure happen, you will know what is the data. Okay, you test it several times, you get the more or less the same data, and then you can see what data represented. Okay, so 17.6 shows metal bag life expectancy for stainless steel belt from figure equation 17.4. E is equal to 28 MSI and Poisson ratio V is equal to 0.29. The bending stress correspond to the 4 entries of table. This this using a natural law transformation and stress space. Show the regression line is at stress equal to this, get and P is the number of belt pass. Okay, what is the belt pass? What is the belt pass? Meaning that every time the belt cycle, the belt is cycling, one cycle is one time, two cycle two time, and then the machine when do testing, the machine operate that at 1,000 time now. You see here, equals to more than 100,000 times. Okay, equal to more than 100,000 times. Okay, you can see, you can imagine the timing belt in your car, the timing belt in your motorcycle, in your bicycle. They have rotated thousand and thousand and thousand of times. Okay, uh, this is called the belt passes lah. Okay, this is 17.6 belt life for stainless steel friction drive. This is the minimum pulley diameter. This is the typical material properties lah for the material. You can see the yield strength, you can see the Young modulus, and also the Poisson ratio. This is the stainless steel. This is BE copper, carbon steel, titanium, and Inconel. Okay. Belt data considered from belt technologies Agawa mask. Okay, the selection of metal flat belt consists of following step. Okay, this is how you select the flat metal belt. Okay, of course from table 17.8, when in industry there are many more type of material. Okay, this table is only a little bit of it. Okay, the idea is you know how to choose. Okay, all the data must have the following. That is the yield strength, Young modulus, and Poisson ratio. Is enough for you to make a calculation for it lah. Okay, this is the selection of flat metal belt. Consider the following step. If you can remember, for the elastomer belting, the polymat, the polyurethane, and everything, the belting that we have discussed before, they have a step. Okay, they have step. But for the flat metal belt, this is the step, the different step, because you have to do some calculation, everything. Again, when you I want you to study MathWay. Okay, to learn MathWay by yourself. Okay, and it will help you to calculate. Okay, the first one is find exponential f theta from geometry and friction. Find endurance strength. Okay, and find the allowable tension from this equation. Okay, and then find the difference of the force equals to 2t over d. Find the slack side. Okay, find the initial tension. Okay, find the width minimum, and choose between width minimum, everything. This is and check the frictional development. Why do you need to check the frictional development? It because you want to avoid slippage. Okay, meaning that to avoid that belting to fly away. Okay, to fly away from the pulley. Okay, not rupture tau, but the belting may fly away. Okay, this is how you do the equation. Okay, example 17.3. Okay, a friction drive stainless steel belt runs over two 4-inch metal pulley. Friction equals to 0.35. The belt thickness is to be 0.003 inch. For life exceeding 10,000 belt passes with smooth torque, KS equal to 1. A, select the belt if torque is to be 30 pounds per inch, and B is to find the initial tension, F1. Okay. From step 1, theta equals to theta D equals to theta. Therefore, exponential 0.235. From step 2, the strength is like this. Okay, failure strength is 14.17 equals to 51,210 psi. From step 3, 4, 5, and 6, you get the largest allowable tension equals to 85.1 B. B is the diameter, but you don't know the diameter yet. The width yet. Okay, B is the width of the belting. You do not know. You want to find it. Okay, and then this is allowable force. Okay, Fu2 is the slide loose side tension. Okay, equals to largest allowable tension minus difference in tension equals to 85.1 B minus 115. 15 given in the question. 15 given. 15 not given. Not given. Okay. Yes, 15 you get here. 15 here, and then you get this equation 3 from step 7. B minimum, you put all the equation and you get the minimum. B minimum is 0.24 inch. This is the minimum size of the width of the flat belt. Okay, smaller than this, the belting will fly away. Okay. Okay. Slack available 0.575 inch width kinetic. Okay, you get this equation. You get the friction development equals to 0.05. Then you check with the friction given in the table. You get 0.35. Whether the equation is okay or not, friction development is okay or not okay, and then you decide. Okay, again, if you answer like this, for example, your answer is 0.35 and you get 0.34, is your answer is okay or not okay? Okay, if your answer is, like say you get 0.34, is slightly lower than 0.35, what is your opinion? Okay, it will not slippage. It will not slippage, but it's better for you to make it as lower factor than that lah. Meaning that making the width larger and everything, so that the it will not over. It will not over, and you must add some factor of safety lah, kan? Okay. Okay, B belts. I think that's all. I have to explain for today. It's already 12:30. Okay. I think that's all. I think I have to stop at B belt. We continue on B belts on Thursday lah. Because I've done a lot of talking, kan? Okay. I'm not sure you concentrate or not lah, kan? Okay or not ni? Okay. Okay. So I think I have to stop now on the B belts. I continue on Thursday. Okay. And for the test, you just practice what I give tip in the WhatsApp group lah, kan? All the tips I mentioned in the problem lah, not the example now. The tips for chapter belting is for in the problem now. It's not in the example. Okay, you can learn from example, but what I mentioned is in the problem section, not in the example section. Okay, you find the solution manual in the internet, in the Google. I'm sure you some of you find it. Okay, you study the problem in this textbook. Okay, so ada soalan? Are there any question? Are there any question? Yeah? No, okay. Thank you. Thank you very much. Okay. That's all for today. Wish for the best. Sama-sama kita jaga diri from this COVID and everything lah. Okay. Okay, jumpa lagi lah. Kan?